Hello friends, welcome back to your UPSC. Today we'll start with another topic of geomorphology, that is tsunami. So let's get started. So, tsunami. Tsunami actually came from Japanese language. Okay? It is a Japanese word which means harbor waves. Okay? So, so these are harbor waves and these are the waves that are generated in ocean. Okay, they are basically the waves that are generated in ocean. And what generate these oceanic waves, that is high magnitude earthquake. So the high magnitude earthquake on the oceanic floor. Okay, what will happen because of the shaking of earth or oceanic floor, waves will be generated on the surface which will lead to tsunami, and the magnitude of earthquake will be like exceeding 7.5 on Richter scale. Okay, next is violent central volcanic eruption. Okay, so there are fissure volcanoes and there are volcanic cones. So when volcanic cones, they erupt in oceanic floor. Okay, the, because of this explosion, what happens is the surface waves of surface of the ocean, it on the surface the waves are generated, and these waves are known as tsunami. Next, massive landslide. So what happens is there are various mountains, shelves, continental slopes, etc. Okay, so these things like mountain, guyot, etc., they submerge, they actually, the part of them, it slides down. Okay, like in landslide on the land, on the crust, same way in the on the oceanic floor, when it slides down, because of this what happens is there is a movement in water, and this movement in water generate waves, and these waves are known as tsunami. Next is submergence of continental shelves or slopes. See, we have done in plate tectonics that due to movement convergent plate boundaries, due to the movement of plates, we have divergent plate boundaries and convergent plate boundaries. So what happens is when the oceanic crust, it submerges. Okay, so what happens is continental shelves and continental slopes also may also submerge, and because of which the earthquake is generated. And because of this earthquake and this movement, there are waves generated, and these waves when come to the harbor, they are known as tsunami. Next is underground explosion. See, like volcanic eruption, there are various gaseous explosions also in beneath the earth's surface. There are various gases which erupt out. Okay, so because of this eruptions, same like we have in volcanic eruption explosion, the gaseous explosion causes movement of water surface, which leads to tsunami. Next is meteorite explosion. So meteorite explosion is also one of the major cause of tsunami. During Cretaceous period, what happened was a a huge meteorite, it fall down on the earth's surface, and it fell on the ocean. So because of its impact, waves were generated, and these waves lead to a huge waves. Okay, and this wave was known as tsunami. These waves were known as tsunami. Okay, so they are basically, tsunami is basically long waves that are traveling at a very high speed. Okay, and have shallow depth in the deeper oceans. Okay, now we will look into basic terminologies of waves. See, we have waves like this. Okay, they move up and down motion, in up and down motion. Okay, so The highest point which a wave reach is crest, and its lowest point is trough. And the distance between two consecutive crest or two consecutive crest and two consecutive crust is known as wavelength of the wave. Okay. Next is run ups. Run ups. Okay, see, we have a wave. So when it reaches to the harbor, there can be two cases. Either the trough, that is the downward part of the wave, hits the shore first, or the crest hits the shore first. Okay, so the case in which the crest hits the shore first is known as run ups, and the case in which the trough hits the shore first is known as drawdown. Okay, now these were the basic terminologies. Now we will look into the characteristics of tsunami. So the basic characteristics of tsunami is, see, as the tsunami is wave, okay, waves in oceanic water. So waves, velocity of waves can be calculated by product of product of under root of square root of gravitation and the depth of the wave. Okay, so with this we can conclude that velocity is directly proportional to the depth of the wave. Okay, so as the depth of the wave increases, the velocity of the wave will increase. Okay, as the amplitude will increase. Now, transformation of energy. So in every physical activity there is transformation of energy. Same is the case with the waves. So here what happens is the energy is transformed from kinetic energy to potential energy. See, when the waves are moving in the water, they are in kinetic energy, but as soon as they hit the shore, okay, this kinetic energy changes into potential energy. Okay, and this is due to law of conservation of energy, which says that energy can neither be created nor be destroyed. It can only change its form. Okay, next is rate of energy loss. See, we are, see, whenever we work in the day, we in the morning we all are having highest point of energy. Okay, and at night all our energy is drained out. Okay, so in this whole time duration we are having energy loss. Okay, same is the case with wave. So the rate of energy of wave is inversely proportional to rate of energy loss of wave is inversely proportional to the wavelength of the wave. Okay, so if the wavelength is more, then the energy loss will be less, and if the wavelength is less, the energy loss will be more. Now we will look into the major regions which are prone to tsunami. So we are very familiar with this region, this area. Okay, so this is the area where earthquake, volcanic eruption takes place, and this area is also prone to tsunamis because of volcanic eruption and earthquakes. Okay, then we have these areas, that is India, Myanmar, and all these island countries with Australia. So this is the area where we have Pacific Ring of Fire. Okay, and this is the area where we have Indo-Australian Plate converging with Eurasian Plate. Okay, so because of this movement, tsunamis are generated due to earthquake. Okay, so these are the major areas where tsunami occurs. Next we will look into hazards. So due to tsunami, three types of hazards are caused. Okay, so first, the major impact is known as primary hazard, then is secondary hazard, and then is tertiary hazard. In primary hazard, whatever, when as soon as the waves hit the shore and they come on the shore, okay, so this destruction which they cause, this immediate destruction is known as primary hazard. And after they hit the shore, they carry away various like fertile soil, erosion, and causes fire, destruction, floods, and all this. This comes in secondary hazard. Then tertiary hazard is after they have left the shore, we can see that there is our plantation has been destroyed, our lives and property have been eroded away. Okay, so we have the damage and loss of life and property, and our whole cultural landscape is damaged. In cultural landscape we can include our fields, okay, our plantation area, hospitals, etc. Whatever man-made created thing comes under cultural landscape. Now, lastly, we see how can we manage these hazards. So, early prediction, early mitigation, and rescue, relief, and rehabilitation with along with the cooperation of local governmental authorities can help us to manage these hazards. So, this was the basic idea about tsunami. So, guys, that was all for today. I hope you enjoyed the class. So, let's meet in our next lecture. Till then, take care and have a nice day.